for basic integers, but more complex data types, such as classes that we're creating, the classes have several data members and they have several functions associated with them. So if you pass a copy of everything related to a class object to another function, you literally get a copy of it that you can read the values, but you can't do anything to alter the values. But it's a lot of memory to pass, to throw on the stack. Whereas if we pass a reference is basically a constant pointer. So there's less information that has to be pushed onto the stack. If there's less information that's pushed onto the stack, that's less operations that your computer has to perform, and your code executes more quickly. Right? So we try to minimize then, right, the amount of information that we need to put on the stack. And that's one of the reasons we use references. Another reason is that a reference allows us to change data in another file outside the scope. So from outside the scope of local function, if we want to change data, we can use pointers, we can use references. Sometimes though, when we give a reference or a pointer to something, we only want that function to read our data. And so we use the const keyword to guarantee that our data becomes read-only, right? And so we've looked at this example before of how to swap two values. Here in this slide, right? Here in main, we've got two values, x is 3 and y is 5. And if we call the function swap1 and pass it the value stored in x and the value stored in y, if we go up here and look at swap1, these parameters are just ints, right? Int a, int b, value parameters. And so when we call this function, it's called a pass by value. We pass the value stored in this x to this a, so a will become 3. The value stored in y here in main's y, 5 gets then passed along to b. Within this function, then, right, we're going to store what's in a in the temp variable, right? We're going to write b over a and then take temp and write over b. And basically what we've done is we've swapped the contents of a and b. But the values here in a and b are only local to this function. As soon as this function exits, right, a and b go away. That has in no way affected the values of x and y back here in main. So we said earlier, well, if we want to actually then affect the values outside the function, we can write it as we have in swap2. So when we call the swap2 function and we have the arguments x and the argument y here, within swap2, we have defined that as a reference to an integer, and so a here is a reference to an integer, b is a reference to an integer. So when we call swap2 and we have x here, well, up here, a gets a reference. It gets a constant pointer. And by a constant pointer, what I mean is a will not be allowed to point to anything other than what it references. So it references to x. That means nowhere in here could we make a point to anything else. Right? Same way here, b is a reference to an integer type. Well, we've passed along a name y, so b is a reference to y's memory. We cannot reassign a reference to point to anything else within this function. But since these are references, then a will be able to overwrite whatever's in x's memory, b will be able to overwrite whatever's in y's memory in this other function here. And so that's what this function does, it swaps it out. So we would see, right, when we call swap1, and come back from this function, x and y are not changed in main, but when we call swap2, x and y have been changed. So that call by reference parameter, it gets a memory address for those values. We're allowed to change that. That's the idea when they're references and they're not constants. All right. And then references versus pointers, right? We could have written this with a pointer as well. The pointer notation is a bit more difficult because notice when we have a reference here, we can just use these as if they were regular integers, right? The names a and b. We know that if we're working with a pointer, we want to read what's in memory, then we need to use that star, that indirection operator, and the notation becomes a little more difficult to read and a little more difficult to write. So references are generally implemented actually using pointers underneath. Right, but in such a way that the reference cannot be reassigned to a different memory address. That's why I said, right back in the other one, a could only point to x. We couldn't make it point to anything else. If we had made a a pointer, we could change a to point to something else within that function. There's no reason why we want to, but it could happen. So just think of a reference variable as another name for an existing variable. It's just sort of a nickname or an alias. And once the reference is initialized to that particular variable name, so in other words, once that parameter A was initialized to be a reference to X, it can't be changed to refer to anything else. Right? Now, pointers store the address of a variable. They're not another name for an existing variable. As I said, when we use them, we have to use the dereference operator, right? The star, to access the address's memory, and they can be reassigned to different memory addresses. Right? They can also be assigned a null address directly. You can't assign a null to a reference. Right? So the big difference is that pointers can be reassigned to point to different memory addresses. A reference, once it's initialized, to basically point to something or refer to something, it cannot be reassigned to point to anything else. That's the key difference between the two. Right. So here is our swap function now, right, with the pointer parameter. So now in swap one, instead of ints, this is an int. These are both int star. So these are both pointers to memory. And you can see here then, if we want to access the memory to which, because A is a pointer to an int, its data type, to access that memory, we use this indirection or dereferencing operator, star A. And that reads what's in A's memory and stores it here in temp. And so star B reads what is in B's memory. And so what B is pointing to, sorry, what A is pointing to, what is in A's memory is an address. And star A points to the address that A is pointing to. So it goes to that memory location. So A points to some memory location, star A says, go to that memory location and read that address. Right? So you can see here, we have to use the indirection operators with the pointer notation. Now, if we wanted to, we could have made these pointers within this function point to some other area of memory. Like I said, we have no logical reason for doing that, but it could be done. Within here, right, we can't make these references point to anything else. Like I said, this notation is much easier for us to use. This is much easier for us to refer to variables as A and B. So we tend to, whenever we can, right, pass things as references to reduce the amount of overhead when we pass information, and also in the case where we do need to change memory outside of our function, or access memory outside of our function, I should say. Sometimes we want to change it, meaning we want to write to it. Sometimes we only want to read from it. All right. So as I just said, right, that allows us to change whatever the object's member variables is. But if we only need read access to something, then what we do is we place the constant modifier before the parameter type. And that's what we saw before in the class Point2D. When we made that friend function here, if we say const Point2D ampersand, where the ampersand is a reference, a constant reference means that when we use this object P1, right, remember friend functions can directly access the class data members. Well, this says you can access the class data member directly, but you can only read from it. So this const makes this reference read only, and this const makes this reference read only, meaning P1 and P2 can directly read. We had X and Y data member values. It can directly read those, but it cannot overwrite those. And so that protects the data in the function, right? That lets the user know that these are going to be constant references. We're only going to read the data within this class. We are not going to overwrite it. And we also do that as a level of protection. If we only need to read the data, well, by doing this in our code, if we accidentally write code in a way that would have an effect of overwriting the memory, the compiler will catch that and tell us about that. So we do that to protect that data. All right. So reference parameter const modifier means it's a constant reference to something, means it's read only. All right. So in a member function, we can also use the const modifier. And so we saw that in Point2D, and I said we'd discuss it later. We're discussing it now. So notice then we made this function called output. it was a member function. It didn't return anything. We were passing it a reference to an OStream object. And the keyword const after the end of the function header says that this function as well will only read the data. So this is a class member. And whenever you put a const at the end of a class member function when in its declaration, that says, okay, this function is making you a promise that it's only going to read the member data. It will not overwrite the member data. Again, that's helpful if when you're writing the function, you actually do something, accidentally do something to overwrite what's in the memory. Again, the compiler will say, oh, no, you said this was a const function. So it's a const function. That means that class member function can only read its own data. Right? And again, then we have to start remembering, well, where does the const go? The const not only goes in the function prototype, it also goes when you actually write the code or define the function as well out at the end. Like I said, after a while, if you write these long enough, you remember where to put it. If you're writing this code all the time, you begin to remember these. Otherwise, if I haven't written things in a while, I have to go back and take a look at, oh, okay, where does the const go in whenever I write a member function? Again, then this output function, all this is doing is guaranteeing we're going to read the data. So const at the end of the header says this member function will only read the data. And that can become important later as we learn more advanced concepts in C++. You can actually make objects that are constant objects, just like we can make other like constant ints and constant strings. We can make class objects that are constants, meaning we're going to initialize them to some value and they'll never change. And if we do that, then we also need to have const member functions to work with those objects. But that's a subject for another day. Right? C++ is a very rich and very complex language, my opinion. All right, so here is what our class looked like, that Point2D class. We saw with a friend function, we have the const modifier here saying that these constant references will only read the data. Here in these member accessor functions, we have a const at the end saying, okay, we're only going to read the data. And same way here in this member function as well, this const says this output function will only read the data. So those are some definitely here within a function heading. This is definitely a new use for us that we haven't looked at yet. Basically, remember const at its very basic value means make something read only. If you remember that, that will help you know that these all work in the same way, right? And we'd already taken a look at this code in the previous lecture, right? And gone through that. This was just simply to talk about what those consts were doing in there. And that's actually then the end of our discussion on consts. Again, this last slide, again, is just saying whenever we should just be able to read from something, if you've got references, if they should just be able to read, put the const there. If you have a member function and all it should be able to do is read, we tend to put the const there as well. Self-test here. We've got these definitions now that we've seen in code. So given these definitions, const int x equals 7. So each of the three const keywords is a promise to the compiler that the compiler will enforce. And we say, what is the promise in each case? Well, if you remember what I just said, that const means things are read-only. So when we say const int x equals 17, that means once we assign this value of 17 to x, we can never override it again. We can always read from x, but we can never override it. Here, with this member function for this class A, the const keyword guarantees that the code within this function will only read data members. It won't write to them. That's what this const does. So again, read only. Here in this member function G, notice we have a reference. Well, the constant reference means that, again, we'll only these, so X is an object of some type. It's a reference to this class type A. What it says is that X will only read its members, its data members, right? It won't write to them. So X is an object of type A. It's a reference to that. It says, I'm going to only read my data members. I am not going to overwrite them. Again, const means read only. So 3 different ways in which we have seen to use it. And we can use it with pointers as well too. Constant pointer means that that area of memory is read only as well too. If this were a pointer to A, that would mean that the pointer is only going to read from that memory. Again, const means read only. And that finally is the end of that. Right? Next lecture will be on operator overloading.